My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 199. In this lecture, we will try to understand relationship between the odds ratio and the coefficients of the independent variables. In my previous lecture, that is in lecture number 198, I already discussed the procedure to calculate odds ratio. In this lecture, we will try to calculate odds ratio with the help of coefficient of the independent variables. This is very useful relationship. How this relationship is useful for finding odds ratio, we will try to understand. This particular result, logistic regression result, I already discussed in my previous lectures. That is the screenshot of some portion of that screenshot we are keeping here. Now, how it is useful, we will try to understand. You must understand here one thing. What is your odds ratio? I can write your odds ratio is equal to e power or exponential e power beta I, isn't it? Beta I is a coefficient. What is your beta I? Beta I is a coefficient of what? Coefficient of independent variable. Coefficient of independent variable. In this series of lectures, which one is independent variables? Chord and spending. What is the difference between these two variables? Chord is discrete variable, whereas spending is continuous variable. Chord can take only two values, 0 to 0, 1, but whereas spending is continuous variable, isn't it? What is the this relationship between the odds ratio and the coefficient of independent variables? We will try to understand. Just see this one, estimated odds ratio e power b1. What is this e power b1? I can say b1 is coefficient of x1. What is your x1? Amount spending. This is x1, it is x1 variable. This one is x2 variable, isn't it? Now, estimated odds ratio is e power b1. b1 means coefficient. Whose coefficient? Spending coefficient. That is 0.3416. That's what I am writing here. What is this? E power 0.3416. Therefore, what will you get? 1.41. This is for which variable? For spending, amount spending. In similar manner, I can calculate estimated odds ratio for which variable? For chord. That is e power beta b2. What is the coefficient? Coefficient is, this is coefficient column. b2 means 1.0987. Approximately you will get 3.0. This I already discussed in my previous lecture. We calculated this odds ratio for b2, in the sense for chord. Even you can calculate odds ratio with the help of the coefficients of independent variables. Is it not? It's simple and straightforward, isn't it? The odds ratio for independent variable represent the change in the odds for 1 unit change in the independent variable, holding all other independent variables constant. Odds ratio. Now, so far we have seen there is 1 unit change. Then we have seen what is the corresponding effect on the dependent variable. Sometimes what will happen? What is the meaning of 1 unit change? Suppose we have taken, what is the meaning of 1 unit change? We were discussing about Siemens credit card. What are the possible values for Siemens credit card? x2 equal 0, x2 equal to 1. It can take only two values. It may have credit card. The customer may use Siemens credit card or may not use. Means there is how much change? x2 equal 0 to 1 means 1 unit, means 1 unit change. 1 minus 0 means 1 unit change. If there is 1 unit change, we have seen effect of that on the dependent variable. In this context, what is dependent variable? Coupon, isn't it? Effect on the dependent variable. For example, this is the discrete variable. If the independent, this x2 is discrete variable, means using Siemens credit card or not using, it is using is coded as 1, not using 0. It is strictly, it's a discrete variable. If the independent variable is continuous variable. For example, x1, what is your x1? x1 is amount of spend, annual amount of spend. Suppose someone is spending $2,000. What is the probability that people will use the coupon? Isn't it? People will use the coupon. Now, we can see $2,000 to what is the probability people will use coupon? We can see $2,000 to $3,000. $2,000 to $3,000 means what? Here, let me say x1 equal to 2 to x1 equal to 3. What is your x1? Continuous variable. I can say x1 is $2,000 to $3,000 means what is the change? 3 minus 2 means again it's 1 unit change. But what happens instead of 1 unit jump, we can go for 6 or 5 unit jump at a time, and corresponding interpretation we can find that corresponding impact. That is the meaning of the change of more than 1 unit in the odds ratio. The odds ratio for the independent variable represent change in odds of 1 unit change in the independent variable, holding all other independent variables constant. Suppose that we want to consider effect of change of more than 1 unit. Let me say more than 1 unit means, let me say it is C units. For example, suppose in the Siemens example that we want to compare the odds of using coupon for customers who spend $5,000 annually, that is x1 equal to 5, to the odds of using coupon for customers who spend $2,000 annually, that is x1 equal to 2. The increment is not 1 because it is 3. How do you know? $5,000 means we are coding as 5. $2,000 means 2. 5 minus 2 means what is the increment? Increment is 2. The increment is not 1 because it is 3. Okay. In this case, C equal to 5 minus 2, which is equal to 3. And the corresponding estimated odds ratio is very useful. What is the corresponding estimated odds ratio? E power C into B1. C is change. How many units change? 3 units change. We already discussed what is B1. You are getting 2.79. This result indicates that estimated odds of using coupon for customers who spend $5,000 annually is 2.79 times greater than estimated odds of using coupon for customer who spend $2,000 annually. You see that the increment is not unit increment. It is 3 times increment. In other words, the estimated odds ratio for an increase of $3,000 in annual spending is 2.79. This is here in this context. What is the value of C? Value of C is 3. Even we discussed about what is G test and Z test in our previous lectures. Here you must understand one thing. What is the use of, what is the purpose of G statistic and Z statistic? As I told you, because of the unique relationship between the estimated coefficients in the model and the corresponding odd ratios. The overall test for significance. This is overall test significance. Where is this overall test for significance based on G statistic? It is also used to test overall significance for the odds ratio. We already discussed G statistics is useful to test overall significance of the model. In similar manner, it is used to test overall significance. This is important. Overall significance of the odd ratio. But the Z test or world test for the individual significance for the corresponding odds ratio. This is similar to, how can I say, we already discussed in previous lectures. You have G test and what is this, F test and Z test and T test. Z and Z, F and T, this is related to linear regression, isn't it? Linear regression. Whereas G test and Z test are logistic regression. Anyway, just these are few simple points. Just try to understand. I will spend a lot of time on these concepts in future classes. Time being, let me stop here itself. Thank you.